welcome everybody. This is another episode of Voices of Sample Management. Thank you for joining. Today I have a fellow Titian product manager, Matt. Could you introduce yourself?
Hi Toby. Hi everyone. Thanks for that. So yes, as Toby says, I'm a product manager here at Titian. I started my career as a software developer. Started at IBM. Worked there for about 6 years before moving to Titian Software, also as a software developer. So worked on many product changes, seen the product grow. I've been at Titian for now 13 years, I think. So I was a developer, then I became team leader and project manager, so leading the development team through a number of different enhancements to the product. And then in the last few months, I've joined the product management team.
Cool, thank you. Today's topic is when and why do you need requesting in your inventory management system. We'll be going through the why do you need it, and also the things you should be asking of your inventory management system, thinking about what you need if you're purchasing or asking for upgrades. So I suppose let's start with inventory management. That's all about finding things in freezers and what the concentration of a tube is, etc. Why do you need an ordering system on top of that?
Okay, so when we're talking about inventory management, obviously it's keeping a database of everything that you've got in the system, what labware it's in, normally tracked by barcode, and having an inventory search to be able to find the substances you want, to be able to view what's available in the system, the amounts and concentrations of everything, with the aim of being able to find the samples that you're looking for in the store and be able to pick them. And that sort of self-service model can be fine, but it's not very scalable. As soon as you're in the situation where you might have multiple different stores, different freezers dotted around the place, your samples you might have many instances of the same substance, again dotted around. They could be in different forms, or so solution or neat. You might need to solubilize them. You might need to take aliquots from those samples. You might want to create plates. There's a lot of process involved there. There's also the decision making about exactly which sample to choose when you've got a choice to make. All those sort of decisions sort of distract the scientists from their day job, when really they just want to say, I want this substance and I want it in a particular format and I want it delivered to me. Don't want to have to worry about the logistics of preparing the sample. So that's where a centralized sample bank can really help with efficiency and with scaling. So you have an ordering system that allows the scientists to say what they want, and then the ordering system will do all the calculations for you, working out what the best sample for your need is and what the processes are that are going to need to be done on that sample. And then the staff in the sample bank, who are sort of experts in using the lab equipment, can then go and prepare those samples for you, and just deliver them to the scientists exactly as required, without any of that effort being put on the scientists.
Okay, cool, thank you. So yeah, I suppose we're talking requesting, so you basically got a black box sample management, and scientists wanting to run assays, etc. But they want to concentrate on the science, is basically what you're suggesting, rather than coping with all the logistics of maybe shipping items around the world and running liquid handlers, etc. Being experts in that. That's diluting their scientific input, I suppose. So that's why we see lots of requesting tools out there. What sorts of requesting are there? You've already talked about barcode, so I suspect a by barcode request is fairly simple.
Yeah. So sometimes you just want to say the substance that you need, and that's all. But sometimes, for example, if you're doing a follow-up, or you want to use exactly the same source as used previously. So being able to order by barcode can be useful. Or sometimes you might have your inventory tool can have logic in it to suggest a specific barcode, and then you want to order that. So having the flexibility to be able to choose how you order either by substance or by barcode can be really useful.
Yeah, and I suppose the scientist is really usually only cares about the substance unless there's a critical reason of why you need to go back to the same tube to maybe run an N of 2 or N of 3 from the same source. So by substance, is there a further complication there, I suppose, from is it close by, is it in your freezer in your lab, is it halfway around the world in China or somewhere? Maybe this what things need to go into a calculation if you've got a by substance, but you may have more than one sample of that substance, for instance, tube or plate or neat or 10 millimolar concentration, 1 millimolar concentration. So what sort of issues does the requesting tool need to cope with there?
So it needs to see what's available. So obviously if the sample isn't in the concentration or the form that you're looking for, it needs to work out what it needs to convert that availability to what you're actually looking for. So it might do some calculations there of a dilution. It's going to calculate whether somebody else might have already put a request in on the same sample or the same substance, make sure there's no overlap there between requests, and sort of gracefully decide who gets what without any conflict, that sort of thing. So
almost like a hotel reservation, you can't both book the same room, sort of thing.
That sort of thing.
Right. Yeah. Okay. I suppose reservations, but it's also potentially the process may not just be I want a tube of this item and this substance. It might be you want something more complicated, such as worst case an echo dose response plate, or even worse, maybe a pooled plate with multiple mixtures in every well. So how does the requesting tool have to cope with those sorts of things?
So it needs to obviously it needs to know that if there's a complicated workflow involved, possibly multi-steps via intermediates, all of that needs to be sort of built into the system, so that if the end user only really cares about what the plate they're going to get out at the end, but that might hide a lot of complexity. Different machines need to be used, different types of labware involved. All of that the system needs to understand that and be able to work out what machines are available and where the process, what processes are needed for that, to have all that logic built into it.
Okay, and I suppose let's talk about one of those workflows. It could be as simple as going from a tube to a tube. Maybe it's a vial of neat small molecule, and you've got to get it into a automation compatible system. What sort of things have to exist in that workflow? I'm guessing. Is there enough of the neat in order to go to make the right volume of solution?
Obviously, if it's neat, we're going to have to work out how much solution can be created from that. If there's too much neat, then it's going to have to calculate how much is going to be weighed out. So there might be a dispense done first into another tube, which is then solubilized to the right concentration, but at probably far higher volume than you're going to need. So the system then has to work out how much needs to be cherry picked from that initial tube into a sample plate, or there might be via an intermediate plate. So if you're using an echo, which has very small amounts, you might have to do an initial cherry pick into a higher volume plate. And and then that will then be the source for using on the echo. So yeah, a lot of steps there.
So I suppose this is all sounding really quite complicated for the poor requester. Have they got to figure out, the entire workflow in order? Have they got to understand the workflow in order to make this happen?
Well, no. So that's where a good software system will do all that for you. And so basically, the requester will put their request into the system. The system will work out, will sort of know what workflows are possible and what steps are needed, and automatically create you the workflow that matches the request. So it will should come up with a step-by-step process of everything that needs to be done to fulfill that request, and then someone in the sample bank can see that workflow and be guided through it step by step, not having to do any calculations themselves, just being basically guided through how much and what samples they need to bring where. It could be as simple as then just taking the effort away from the sample bank staff.
Okay. And I suppose stopping them making mistakes as well. That's
exactly,
that's the ideal.
The sort of human error that can creep in if you're having to do those sort of calculations
on a post-it note or something like that. Yeah. It's just I've never seen it done before in my time at Pfizer. Never. So I suppose science moves on. We've talked about simple dose response type work. Even single point. I've got a plate of 96 individual substances, all at the same concentration. But it can get a bit more complicated than that, can't it? With the move to mixtures and pooling. How does ordering cope with? How does the request system cope with that?
Well, so you need to be able to request the substances you're requesting. Need to be able to specify which ones are going to be pulled together in the final output. So you need to have a system that not only lets you list the substances that you want, but also how they're going to be mixed together, and give you some way for the requester to specify which substances are going to be going into what mixture.
Okay. And it's almost sounding like a request system could be really quite simple. I mean, I'm thinking when I go on my phone and use a certain river-based software on it to order items, you can get a long list of curtain rails or whatever it might be you're looking for, but it's really quite simple to order. But I suppose in some cases, mixtures creation, you might have a more complex order than just your river-based ordering system, if you like. Can you explain? Is there potentially two types of ordering?
Yeah, so again, it's about flexibility. So as you suggest, the majority of people using a requesting system will probably do things in the most simple way, just add their items and click go. But a good system will have the flexibility to allow for more complexity, mixtures being one of them. So essentially, it's a system that's as complex as it needs to be, but no more than that. So for sort of advanced users, there should be those advanced options. But for anyone who doesn't care about those advanced options, then things should be as simple as possible.
Okay, so I mean, you've talked about a list of items that somebody wants to order. What happens if I'm thinking a project scientist may have very few, unfortunately, especially in the small molecule world, there may not be many items coming in through per week, but they want to send them to more than one assay. Is there, do they have to do, 10 requests in order to make that happen?
Well, again, that should be something that the flexibility of the system allows you to have an interface for doing that. So that's a common scenario that a requester would want to do. So the system should have an interface for that sort of assay requesting. So yeah, so you shouldn't have to be forced to keep putting in multiple requests if you want to put the same set of substances for more than one assay. It should allow you to have an interface that will simply and efficiently pick from a list of assays which ones you want which substances to be submitted for.
Okay, cool. And then I suppose yeah, how confident should the requester be that they're going to get their items, their dose response, their mixtures played?
Yeah, I mean, they should be completely confident that once they've put that request into the system, that the system should run an upfront check to make sure that what they're asking for is fulfillable. And once the system is given the green light, the requester should have full confidence that what they've asked for is what's going to be delivered. And obviously, if what they're asking for can't be achieved, then they should be told that up front as well. They shouldn't have to wait hours or days and to then be told that, sorry, there was a problem with your order. They should be told straight away, and then they can make the necessary adjustments if they can to order something different or a different amount.
Okay, and then I suppose another awful scenario might be where Project X doesn't want Project Y to use Project X's substances for the first 6 months or something like that, because they've been bought, designed for Project X. Does a restriction system maybe exist in these as well?
Yeah, so again, that should be a functionality of the system that you can place restrictions on certain substances or lab items and say that these are reserved for a particular user or set of users, and then the system will know that if somebody else tries to order those, then it should let them know that they can't do that. But it should also know that if someone who is allowed access, they should have access straight away. There shouldn't be any kind of wrangling needed. They should just get what they
require. Yes. Yeah. Okay. I suppose one of the nightmares with restrictions might be that the owner of that substance leaves the company or moves department or something like that. But yeah, that's another can of worms probably. And I suppose a company may have their own interface that they're used to using. Maybe it's an ELN or something like that. Is there does the requesting system need to operate with other systems?
Yeah, so that's fairly standard for requesting systems to have an API, a web service that other systems can call. So that just as you described, so a requester can use a system that they're familiar with to put a request in, and then that gets sent along to the sample bank's requesting systems seamlessly from the requester's point of view, and the request will just get put into the sample bank exactly as if the requester had used the user interface directly. Okay.
And then I suppose downstream of these requests, is there focus on making the sample bank as efficient as possible? Maybe describe what happens post the request. What happens in the workflow within the labs? Is it
Okay.
Yeah.
So yeah.
Such as maybe you have an automated store and everything gets picked for the day's work before anybody even arrives, and is that important as well?
Yeah. So obviously, if multiple requesters are using the system and putting multiple requests in for similar substances and similar workflows, you don't want the sample bank staff to be continuously going to the store to pick just a few items and then running just a small number of samples on a liquid handler just to create a small number of plates. You want the system to be able to bring all the similar work together and show the operator that you've got a lot of different requests that need to be operated on today. So you're going to So but yeah, so basically all the picking can be done for multiple requests in one go to get all the samples ready. And yeah, if you're using an automated store, that could be done overnight. So in the morning, the staff could come straight away, all their samples will be ready. The system will tell them exactly what needs to be done with those samples, and they can all be done on the same machine, maybe in a single run, so that's the machine utilization is as efficient as possible. So, which is
so you mean more than one request could be done on one machine? In a single run. If
it's based on the machine and they're doing similar processes, then yes, it makes sense to do them at the same time.
Okay, and hence the sample management staff can have a longer coffee break. I like that one. Yes. Okay, I suppose we've talked about consolidation, maybe from an auto store, even from a manual store, I suppose, but consolidation on the liquid handlers. What about consolidation? We were talking earlier about multiple projects maybe asking for an assay. Is there any consolidation that can happen there as well?
Yeah, so again, if multiple people are requesting substances for the same set of assays, you don't want to be creating sparsely populated plates, multiple sparsely populated plates for the same assay. You want the sample bank staff want to be able to see that, see all the requesters that have requested for that assay, and be able to pull the work together and create consolidated plates that are as full, as many full plates as you can, and then send all of those in one go to the assayist.
Okay, so and I suppose even better, that doesn't just consolidate the sample bank's time, that consolidates the assayist running the assay, and then they don't have 10 plates, they have 1 plate to run.
Yeah, exactly.
Excellent. Okay. Is there anything else you want to bring up, or is that all we can think about for a requesting system? I think
we've covered.
Yeah. There. Okay. Cool. So yeah, I suppose the take-home message is make sure your requesting system can cope with what you're currently doing and what you need to do in the future. Potentially, you need to do in the future. We as Titian see different systems out there. They all have their pluses and minuses, but the sort of things we've discussed here are probably the questions you should be asking when you decide to either in-house design the requesting system or purchase one. So I hope this has helped of why requesting is so important. Matt, thank you for your time, and thank you everybody for listening into the latest Voices of Sample Management.
Thank you.